Please, I'm not going to scold anyone that how you are doing this wrong. At least try. Amna Mariam. Taha has already sent me the answers. Okay, Amna. So let's see. So the question says the most reactive for the SN1. So in SN1, the halogen leaves, right? In haloalkenes and or haloarenes, we know. Then this will leave, bromine will leave, and will leave a carbocation here. So this will one will be the intermediate for A. This one will be the intermediate for B. Are you getting everyone? This one will be the intermediate for C, and this
Yes.
one will be the intermediate for D. At least please confirm that you have understood the intermediate. Everyone? Oh, sorry, I have left NO2 here. Everyone? If
Yes.
the intermediate is stable, then it will be, the reaction will go on very quickly. It will be the most reactive one. Okay, so let's see which one is the most stable. The most stable will be the most reactive for SN1. So see, NO2 shows, what does NO2 shows? Anyone remember? M plus M minus M, anyone remembers? You know, donation of electron tendency. Okay, plus M means donation of electron tendency. So NO2 shows minus M effect, means it withdraws electron. It withdraws electron. Withdraw means, hope everybody understood, like we withdraw money from ATM machine or from bank, means it extract electron. O2 have the tendency to give electron in the ring. Okay, so it shows plus M effect. It donates electron. Okay, plus yeah, OH group. This is a methyl group, so it shows plus I effect. Means it pushes electron density towards other. This is a CH, and there is nothing here. So everybody, understood till here.
So
NO2 has the tendency to withdraw electron from the benzene ring. OH has the tendency to donate electron into the benzene ring. Okay, got it?
yes.
So see, what is present here? Positive charge. It has positive charge here. It has positive charge here. So in this one, we have positive charge and the electron are still withdrawing. So this is becoming more unstable. Here we have negative charge. Sorry. We have positive charge, and here OH is donating electron into the benzene ring. Here we have methyl group which is donating electron into the benzene ring. Okay, so donation is good here, as we are having carb cation, right? Donation of electron will make this carbocation happy, right? With electron, stability will increase.
Yeah.
So this one and this one are helping the benzene ring, or helping the carbocation to neutralize the this positive effect. Okay, and this one is worsening the situation. Situation is getting very worse. Why? Situation is getting low. Stability is getting more lower form. Why? Because we already have positive here, and NO2 is withdrawing more electron from this here. So this is not good for for the reaction. So this one and this one is good for reaction. Second and third. Did everybody understood this till now?
Yes, sir.
So now you have but the one option this in these two options only one option is correct. So plus m effect is always greater than plus I effect. Okay, so that is why second option is most correct one. Third option is correct, but not correct in front of second option. In second option, oxygen is donating its lone pair into the ring. Okay, that is why. Got this?
Yes,
Uh,
sir.
anyone want a repetition in any one of the case? 1, 2, 3, 4. So second one will be the most reactive, then the third one, then the fourth one. Because the first one is the least stable. The situation is getting more worse and worse. Stability is decreasing. Let me know if you want a repetition or you didn't understood the problem or the solution. Hmm. अरे हाँ ना कुछ बोलो.
Sir, I understood.
Okay. So this concept now we are going to use in elimination, not elimination. After elimination, we are going to use in electrophilic substitution. Kindly note this down. This is very important one. If you have noted, just let me know. As soon as you have noted this, please let me know. Done, Mariam? Sufyan? देखो हाँ ना
Yes,
कुछ
sir.
बोलना पड़ेगा नहीं तो
Yes,
आपके
sir.
कैमरे ऑन करा दे जाएंगे जी. ठीक है, बहुत अच्छा. So let's start the today's topic. Actually, we are continuing the yesterday's topic. Ignore the arrow here. I don't know why it forms arrow. Have I taught you ambident nucleophiles? Ambident nucleophile. Have I? Okay. So maybe I haven't taught. So see, the nucleophiles. Ambi means both or two. Okay. Uh, so they have two heads actually. See, for example, the nucleophiles which have more than one donor site for bond formation. The nucleophile which have more than one donor site for bond formation. So with example, it will be understandable, like Cn minus, okay, like NO2 minus. This will be we are doing the mechanism also, so that it will be more clearer to you. AgNO2, okay. Uh, no, not AgNO2. There's NO2 minus. So see what is happening here. We already did in this AgCN, KCN, okay, AgCN, KCN. But what is actually happening? We are, I'm just will show in some reactions. So what is happening? A nucleophile having two options to attack. That is why it is written. It has more than one donor site. Okay. So let's take the example of this. Is the mentioned in NCERT. A distinct topic reaction under this SN1 SN2 only nucleophilic substitution reaction with KCN and AgCN. There's a lot of difference between the reaction of KCN and AgCN. And what is it? Let's see. Let's have the case 1. Since we have two sides to attack, so we are taking case 1. Uh, with KCN or NaCN or CSCN. CSCN is not much important. Just have NaCN. देखिए क्या होता है अभी. जस्ट वेट करिए, सब समझ में आ जाएगा. When alkyl halide is treated with KCN, then they form alkyl cyanide. Also known as alkyl halide, alkyl nitrile, sorry. So see, let's see the reaction and just feel the mechanism here. So what is happening? KCN, sorry, RX alkyl halide is getting reacted with KCN, and what is it is forming RCN. Okay, RCN, and this the rest product is not much important. This RCN is important. Okay, and what is happening? The mechanism of it. What is the mechanism? Because if you know the mechanism, you will get feel here. KCN is a ionic compound. Just remember, this is the most important thing. KCN is a ionic compound. That is why in solution it will break into K plus Cn minus. How? Like example, you may know NaCl is when you mix in water, it dissociate into Na plus Cl minus. Ions break into solvent, polar solvent especially. So what is happening is we are getting this one, and we have Rx alkyl halide, and we have K plus and Cn minus in the this solvent. So Cn is like this, the structure of it Cn. Okay, the Lewis diagram is like this. And what is happening? We already know that in Rx bond, this X is very electronegative. That is why we have partial positive charge here, right? Everyone, everyone understood partial positive charge on the R. Why? Because X is very electronegative. It is extract electron, the bond pair towards itself. That is why the alkyl group is having positive charge on it, right? Everyone,
Yes, sir.
this thing is coming again and again. So this nitrogen, this carbon attacks on this alkyl group. Okay, and there is other option also that this happen. Nitrogen will attack on, oh sorry, nitrogen lone pair can also attack on this R, but this is not happening here because because here alkyl group is have making bond with carbon. Carbon carbon bond is very strong. That is why this is happening. RCN, and negative charge on carbon is is not good for carbon. uh, carbon uh, Carbon is less electronegative than nitrogen. That is why carbon don't want any extra electron on it, and thus there are these two reasons. You can understand that carbon is forming bond with carbon, with the alkyl group. Understood, everyone? Haji.
Yes, sir.
So for example, let's see with example, like we have bromine here and it is reacting with KCN. KCN or NaCN, है ना? Why KCN, NaCN? We have taken this KCN, like this is potassium cyanide, this is sodium cyanide, because they are proper ionic bond, ionic in nature. That is why. Okay. So what will be the product? Product will be this. Bromine will be replaced with CN. Understood, everybody?
Yes, sir.
Huh. So one note, one special thing what is happening here is, in this chain, can you see we have two carbons present here, and we have total carbon, if you count 1 2 3 carbons present here. So this reaction, so reaction with KCN will do what? KCN, NaCN, anything, not anything, ionic bonds. Reaction with KCN or NaCN is used to increase one carbon atom in chain. Obviously, one carbon is added in the chain, right? Can you see? There are two carbons present here only in the reactant side, and we have total 3 carbon attached in the main carbon chain, right? जी देखो, कैमरा ऑन नहीं करने बोलते हैं तो कम से कम बोलो, कमेंट करते रहो. सुफियान,
Yes.
अंडरस्टूड?
Yes, sir.
Other examples. So this one is mentioned in your NCRT. Okay. So the reason which you have to know, please, I'm just what I have told you. I'm writing this down. Since KCN is ionic in nature, is ionic in nature. Please see, KCN has covalent bond also and ionic bond also. See, K plus is making ionic bond with Cn minus. So here covalent bond is also present, ionic bond is also present. There are some question asked in MCQs that please select that compounds which are having ionic bonds also and covalent bond also. So this is one of the example. Okay. Since KCN is ionic in nature, it dissociates into K plus and Cn minus. Please, from where you have to copy. Have you written ambient nucleophile, everyone?
Sir.
Done ambient nucleophile
Sir.
copying. Taha?
Done, sir.
This one. Reaction with KCN and AgCN? The
No.
introductory part? No.
No, sir.
Please do. Uh, please do it. We will take another case of reaction with AgCN, in which there is no ionic bond present. So we will see what will happen there. That will be a different case. K, potassium, sodium, they are like first group metal. So that is why they always formed ionic bond. This is also taught in you are in class 12th na. This was taught in class 11th. Uh, you may remember. Sodium, potassium, cesium, these they do not ever form a covalent bond. Alkali metals and alkali earth metal, first group metal and second group metal, do not ever form covalent bond. They always form ionic bond.
Okay.
Hmm. There are some points which I mentioned. Uh, you know, as a good student, you can write by you in your in your own words, like why K and Na is only present here. What is happening? See, the carbon has been increased in the chain. If anybody says that, sir, the carbon is of cyanide, but the carbon is carbon, na? The nitrogen attached with the carbon, which is making this cyanide. Nitrogen can be removed with certain processes, but the carbon chain, in the chain, carbon number of carbon atom has been increased to 1. Done, everyone?
Done.
Taha?
Yes, sir.
Hmm. So let's go to the second case. And the last, I have written that carbon and nitrogen both are electron rich, but only carbon attacks on the alkyl to form a RCN, which I have just told you, because CC bond is stronger than. So the catenation. Catenation, everybody knows that carbon makes carbon bond with carbon. So this property you can see here also, that carbon-carbon bond is so strong, so it is likely to form that bond only. So the second case is, case 2 is reaction with AgCl. What is the special thing about it here is, when it is attacking with Rx, the Rx, AgCl, in AgCl, carbon is already bonded with silver with a covalent bond, and we have this structure like this. Okay, on reaction, we get RNC plus AgX. AgX is not important much, but this is important. What is happening? This nitrogen has the lone pair, which has the ability to attack on this uh, alkyl group, since it is having delta positive charge. Okay, why carbon can't attack here? Because carbon is busy making bond with Ag. Ag is a metal, however Ag has the property to make covalent bond. The covalent character is very high here, AgCN. uh, do you remember Fajan's rule? Anyone? Means I'm not going to ask you for definition, just have you heard about this Fajan's rule
Yes,
in
sir.
class 11th chemistry? So Fajan's rule says that no, no ionic bond is 100% ionic. There are some covalent character in it. So here the covalent character dominates. Okay, so Ag is forming covalent bond with carbon. Okay, so the definition also just I have told you what the Fajan's rule says. So understood? The carbon is busy making covalent bond with the Ag. That is why nitrogen lone pair is available to attack on the alkyl group having partial positive charge. Okay, since it has been bonded with a halogen which is highly electronegative. Tell me, have everybody understood this or not? Please
Yes.
let me know. If you means the process has been taken by step. The explanation has many steps on it. Have you understood every steps, or just let me know if you want any repetition or anything? So I'm going to write the statement. Please write with me. Cool. Just let me know when you are done. Done ji.
Not yet.
Well done.
Hmm. So मतलब बात समझ में आई, means here nitrogen has the lone pair
Yes, sir.
which is not busy making covalent characters, so it is attacking on alkyl group and that's thus forming RNC. So finally the ambidient ambidient nucleophile, you may getting the feeling of ambidient nucleophile. They have two ways to attack on the some positive thing, and nitrogen also can attack, carbon can also attack. So it is one of the example of ambidient nucleophile. Understood? The ambidient nucleophile. Okay. The Cn minus we have told na. The Cn minus C can also attack, N can also attack. There is another example where nitrogen can also attack, oxygen can also attack. So let's see. The other thing, reaction with KNO2 and AgNO2. So can you tell me which one will be having covalent character and which will be having ionic character?
He has
Anyone?
ionic. Yeah. Right. Covalent.
Sorry.
Yes, covalent. Silver has covalent.
Okay. Taha, what do you think? This will be
Then what will
covalent
you say?
character or this one will be the covalent character? Where the covalent character can be observed? In the potassium, which is group 1, I have already told group 1 and group 2 metals will always show ionic character irrespective of anything. Just this is very good thing in chemistry because there are a lot of exceptions which you see in the chemistry, right? Like Ag is a metal, but it is forming covalent thing, and the metal have the property to form ionic thing. So there are some exceptions, and it is difficult to remember. So if some statements which are true in every case, that is very good for you. Like this statement, like group 1 and group 2 metals always form ionic bonds. So reaction with KNO2. So in this we know that when KNO2 is is dissolved in solution, it dissociates and form this NO2. Let me draw its figure. It will be like this. This will be having minus charge on it. Okay, and the what is happening here is we have this, and this will be attacking on Rx, and obviously it will attack on R. Okay, there is a negative charge present here, so this will attack on this R, and what it will form R O N, like this. Okay, so kindly write the statement with me. This one you have written. Amna, are you getting?
Yes, sir.
Hmm. You can let me know, everyone. This is for every one of you. You can let me repeat any of the step if you want. You can message me on in chat also. Done. Done ji.
No, sir.
Ach.
Yes, sir.
Hmm. So let's see the second case in which we will be having reaction with AgNO2, and what will happen? Let's see. This is the structure of AgNO2. Okay, and O has already made a covalent bond with silver. Okay, and what will happen here is nitrogen have lone pair on it, and it will readily attack on Rx. No problem at all. Okay, so it will attack on R, and what will it form? You can guess it. It will form a bond with nitrogen. Okay, so this will be the uh, you know structure of it, and this will be the final reaction. And the reason here is because oxygen is busy, and it has already made covalent bond with silver. So nitrogen has the lone pair, uh, and lone pair is also available with oxygen. Some lone pair are available, but nitrogen is lesser electronegative than oxygen. So nitrogen can it donates electron more easily than oxygen. So kindly write with me this case. Let me know when you are done.
Done, sir.
Good. So in the first case, alkyl nitrile was the product, and in the second case, which you can see, uh, nitroalkane will be the product. Done, everybody?
Yes, sir.
Okay. So let's do one question. So let's do one question. So your SN1, SN2 is nearly complete, uh, but we have some good questions available in which a new topic, like subtopic, where carbocation rearrangement is taking place. Have you ever done this carbocation rearrangement thing? Carbocation migrates here and there
No,
within a compound. Anybody? Just yes or no? No problem.
no, sir.
Okay. So see, let's
Are
do a question. Huh?
resonance effect?
No, no,
Resonance
resonance
effect?
effect is different. Resonance effect, I'm sure that you have done in class 11th, but there are high chances that carbocation rearrangement is not, yet introduced to you. So let's understand with the question. The question is uh, within means this time, please note down the question. Uh, wait, let me. So we are having SN1 reaction, and we have this compound 1 2 3 4 1 2 3 4. We have OH group here present here, and we have methyl group present here, and we are doing reaction with HBr. Okay. So this is the question, and we are going to solve the question. uh, so wait a minute. If hmm. So see, what happens is, like, when we are, this is one of the example of SN1 reaction. So in this, no, let me add bromine here. We're having bromine here. That will be the SN1 reaction. So the reaction is this. So see what happens in SN1 reaction. We know that carbocation is formed, right? The halogen leaves and carbocation is formed, right? Everyone. है ना जी? हेलो, अरे कुछ तो बोलो. In SN1 reaction, carbocation is the intermediate, right?
Mm.
Have you forgot SN1 reaction? So in the next step, what will happen? This is a carbocation, and this is a 2 degree. This is a 2 degree, 3 degree carbon. This is a 2 degree carbon. This is a 1 degree carbon. So the carbocation will like to stabilize. Uh, we have 1, 2, 3 carbon attached with it. The fourth one will be the hydrogen. So what will happen? There will be a hydride shift. Okay, H minus will shift. So it will shift here. Okay, and in this exchange offer, positive charge will shift here. Okay, so what will happen? Hydrogen will come here. Okay, and this positive charge will shift here. Okay, a second. The positive charge will shift in this carbon. Okay, so you should know that this have how much alpha hydrogen? Three hydrogen present here, 3 hydrogen present here, and 2 hydrogen present here. So 3, 3, 6 to 8 alpha hydrogen. Hyperconjugation concept. This has 3 hydrogen here and 4 hydrogen alpha hydrogen present here. So obviously 8 alpha hydrogen is more stable than 4 alpha hydrogen. That is why the carbocation has been shifted. Carbocation hyperconjugation thing. Just I will you may have heard this hyperconjugation word, right? Everyone, hyperconjugation.
Yes, sir.
Huh. So for example, if we have this, for example, we have this structure. Okay, positive charge is present here. In another structure, positive charge is present here. Okay, so we have to calculate alpha hydrogen present here, है ना? So how we calculate alpha hydrogen? We calculate it by, this is a carbon uh, on which positive charge is present. So how many carbon just attached with this carbon, and this carbon? 2 carbon are, so these are called alpha carbon. These 2 carbon are alpha carbon. And the number of hydrogen which alpha carbon has is called alpha hydrogen. Okay. So we have 2 alpha carbon here. Okay. So can you tell me how many alpha hydrogen present in this alpha carbon? How many hydrogen present here? Can anybody calculate? 2, right? To satisfy the valency of this carbon, there must be 2
Yes.
carbon hydrogen.
Yes.
Taha, are you understanding this?
Yes, sir.
How many Taha, how many alpha hydrogen is present here?
2.
No, see, this carbon is attached with 1, 2, 3 carbon.
Oh, sir. Okay,
Only,
sir.
only one option is left, right? So we have alpha hydrogen this present. Okay. So total alpha hydrogen present in this structure is 3. Okay. So now let's calculate for this one. We have this. Amna, please check out. This is positive charge. Number of alpha carbon present here is this one, and this one, right? Sufyan?
Yes, sir.
Ha. So we will calculate number of alpha hydrogen. Alpha hydrogen. Please calculate and let me know how many alpha hydrogen present. So I will ask, we have 3 students, sir. I will ask each one of you. So Taha, how many alpha hydrogen present in this one?
Sir, 3.
How many carbon it is? This carbon is attached with how many carbon? This
Sir,
carbon.
2. So this, sir, 2.
So alpha hydrogen should be, huh?
Sir, 2.
2. Yes, correct. Amna, this alpha, how many alpha hydrogen are present in this position? Can you tell me? Amna, please respond.
Yes, sir.
How many alpha hydrogen can you count? I will help you, no problem. Can you count alpha hydrogen?
2.
2, right? Good. Because only 2 options are present, means 2 is already bonded with carbon, so only 2 option is left for hydrogen. So 2 is the Sufyan, how many alpha hydrogen present here?
3.
3, correct. Good. So total number of alpha hydrogen is present here is 3 to 5, 5 to 7. So this one will be the stable one. Okay. This carbocation, this structure is more stable. Okay. Understood? This will come
Yes,
every
sir.
time.
Yes,
Means
sir.
since carbocation is intermediate in lots of reaction. In elimination also. In elimination, when we study the carbocation stability, we will talk about. In nucleophilic substitution. This is nucleophilic substitution. When we will see electrophilic substitution, then also this carbocation stability will come. So every time this will come. That is why I'm focusing you on this thing. Let's see. No, no, I will draw a different structure for you. So please, just let me know how many alpha hydrogen present here directly. Please calculate in your copy alpha hydrogen. And you have to let me know the order of it. Which one is the most stable, the in the increasing order. Just message me in the chat box. No problem if you are getting the wrong answer. Uh, the problem lies when you don't try, when you don't want to try. That is the main problem. So please try, give me the answer. Put stress on your brain and try to calculate alpha hydrogen in all these 4 scenario. You have 1 minute. Please let me know. In this 1, 2, 3, 4 order, just message me how many alpha hydrogens can you calculate. This is hyperconjugation effect which we are studying, means this order thing, hyperconjugation. Amna, Taha, please send me the answer. You can be wrong, no problem. But if you don't send the answer, you don't try, then that will be a problem for you. Done. Taha. Like exams now, you also have to calculate alpha hydrogen. Sometimes you have to calculate number of resonance structure, resonating structure. Sometimes you have to find out what you have to find out, like number of pi bonds, so number of sigma bonds. It is very common for your exam things. So so please check if your answer is correct or wrong. uh, हाँ एक सेकेंड. हाँ जी, तो in the first one we see we have this and these three carbon present here. So number of alpha hydrogen will be 3 here, 3 here, and 2 here. See, like this we have our hydrogen, we have hydrogen here, we have hydrogen, sorry, 3 hydrogen here. So number of alpha hydrogen will be 1 2 3 3 6 6 to 8. Okay, let's count here. So we have 3 here, alpha hydrogen here, and we have 2 alpha hydrogen here, and we should not count this one because they are beta carbon and gamma carbon, so they are not point of means interest of for us. So we have 1 2 3 4 5 alpha hydrogen here, and let's see for this we have 2 alpha hydrogen here, and we have 3 alpha hydrogen here. So we are having 5 alpha hydrogen here, and finally in this one we have 2 alpha hydrogen here, right? So the order is this only. Okay, in these two, how we will comment on it, I'm just for your knowledge sake. uh, so this is getting plus I effect from this alkyl group, and from this and this alkyl, means lots of I effect here, and we have only plus I effect from these two only. So the answer will be in this fashion only. Okay, the thing which I have to tell you means teach you here is counting the number of alpha hydrogen and commenting on the this stability, right? Everybody understood? Haji.
Yes, sir.
Ha. So in this reaction, what we were seeing is we are getting positive charge here, but it will shift to positive here. Okay, the carbocation has been shifted, the positive charge has been shifted because of hydride shift. So hydrogen has been shifted here, and thus this is only possible because stability has been increased. Stability has been increased. Okay, that is why we are getting this component. Okay, अब देखिए we have reagent H2 and NOH. So what will happen finally? NaOH. So OH minus will OH minus will finally attack on this. अरे क्या हो रहा है? So OH minus will attack on this. Okay, and the OH will form in OH will attack on this, and the final result will be this. This will be the final result. Okay, understood everybody?
Yes, sir.
If there would be no hydride shift, let's assume there is no hydride shift, then the result would be like this. The carbocation will be forming here, so the result will be the carbocation will be forming here, right? it has formed here. So it will be attached, the OH will be attaching here only. Okay, but the answer we are getting is this one, not this. So this one is wrong because of hydride shift, because there is more stability in this. This is the final answer. Okay, this we are no, this topic is taught under carbocation rearrangement. Have everybody understood the basic thing? Why it is rearranging and the product is not similar because of rearrangement?
Yes, sir.
Let's see. This thing which is taking time now for you to, which I spend some time for you to revise your basics. Uh, this is very important for you. For me, I could just write that this has been shifted. There is 4 alpha hydrogen here. There is 8 alpha hydrogen. So obviously, due to hyperconjugation, it was more stable, and hence this will form. But I'm giving you 1-2 examples of it so that you can practice on your own, and you will remember for longer period of time. Otherwise these things are can be taught in like 2 minutes. That is it. So let's see with the other examples. So we have 3 methyl on this carbon, and it is reacting. Okay, H2O KCN. Again the reaction is going to be taking place, and there is no hydrogen present here, right? Everybody, can you people understand this? There is no hydrogen present here.
Yes, sir.
So see, obviously the carbocation will form here, and we have this structure. So here the whole methyl group will shift. Okay, CH3 will shift. Okay, so what will happen? This will shift here, and the carbocation will shift here. Okay, so finally this will shift here. So this will be coming here, and positive charge will be will be coming in this position. Okay, so please calculate with me how many alpha hydrogen present here. 1 2 3, either here 0, right? So we have 3 alpha hydrogen present in this position, and we have 1 2 3 4 5 6 and 7 alpha hydrogen present here. So obviously this is possible. That is why this will shift. Okay, carbocation will shift. Carbocation rearrangement is successful here, obviously, because of more stability, and which can be understood by hyperconjugation. Cn minus will attack on this position. Okay, and finally we will be having this structure. Sorry, not minus. Everybody understood?
Yes, sir.
I'm just making a circle for you, that this whole thing has been shifted. Okay, it has been shifted to here, and positive has been shifted to this side. Okay, there is another interesting cheese, means interesting thing is possible in this topic, in which we are going to talk about ring expansion. Ring expansion. So what will happen here is, again, We have H2O and let's assume we are doing some Nick-Flick substitution reaction. So bromine will get out of the this compound and carb cation will form, right? Everyone?
Yes, sir.
And here a ring expansion will take place, and let's see how it takes place. Expansion. Carbon carbon bond sp3, these all carbon in the circle in this cyclic compound is in sp3 state, right? No double bond, so everyone will be in sp3, right? Carbon is in sp3,
Yes, sir.
so sp3 carbon should be like 109 degree, but here what we see 90 degree. So there is some angle strain. Okay, means the reason which I am teaching you why this is happening, this will be not taught in your school. Okay, why the ring expansion is taking place, the reason is this, because carbon carbon bond wants to be in at this angle 109, and it has been reduced to 19 degree, approx 19 degree, more than 90 degree, to 90 degree. So they are feeling some strain. So what will happen, this will bond breaks. Okay, and this will go here, and finally we will be having this. Okay, let me just for your knowledge sake, what is actually happening, this 2 and 5 bond is breaking and this is forming. So uh, from 2, the bond has been broken, that is why the positive charge will shift on second carbon. Okay, on the second carbon, and this will be like this, and 1,5 bond is, this is a new bond which has been formed. Okay, now obviously OH minus will attack on this positive charge, and we will be having this structure OH. Got it, everyone? Or you have doubt in any step, just let me know. हाँ जी, कमेंट तो करो भाई. Any step which you are having doubt or wants you want me to repeat?
No, sir.
Okay. Amna, what do you think?
Yes, sir.
समझ में आई बात? Have you understood?
Ji.
Okay, write major product for following. So now the angle has been increased, right? It is more than 90 degree. It is, I don't remember exactly. It is uh, like 100 something. So angle strain has been decreased. So this is forming in this way. Okay, let's try some questions, and after when you are done, we can this class will be over. Please do this question. Acha, you want to write now? Please write it down. You have to write from carbocation rearrangement, right? हाँ जी,
Yes, sir.
हेलो, कार्बोकेटाइन rearrangement लिखना है ना?
Yes.
हाँ, तो करो. होमवर्क करके आइए, अच्छा रहेगा. You have already solved this question, so done. Ring expansion.
Yes, sir.
अच्छा अच्छा हाँ करो करो. Done. Everyone. Done writing the this ring expansion thing. Hello, Sufyan.
Yes.
Hello. हाँ. So see, let's try to solve this question in a minute. See, or in the first, देखिए सब ध्यान से देखिए इधर. कॉपी कर लीजिएगा, कोई बड़ी बात नहीं. So SOCl2 is reaction with OH thing, and we have this Cl chlorine will be replaced by this OH. Sorry, OH will be replaced by chlorine. That is why this will form. In this one Br2, we have UV rays. So what happens is bromine, this carbon and this carbon, either of the carbon, this will form. A radical will form, and bromine will be attached, because these two carbons, when radical will form, there will be, they will be resonance stabilized. That's why bromine will attack at that point, and it will form bromine. Now in this one we have light here, and this one when we see, we have to put bromine here, right? So bromine is negative. Bromine is negative and hydrogen is positive, right? So when we will be forming this position, sorry, in HBr, have you done this thing, this reaction? Means I haven't taught you this addition reaction. So you may so you may have not done addition reaction. So no, I think you have done. So in this one, Markovnikov rules, right? Everybody done Markovnikov rules?
Yes, sir.
So
Mm.
the halogen will attach there where it means attach at that point where it has more hydrogen. So we have one hydrogen here, and when we have zero hydrogen here, so that is why bromine will attach at this point. The next one, when we will see this reaction, in which what will be the product will be this. I will be forming, replacing bromine in the presence of dry acetone. So this reaction, this is the one of the name reaction, Finkelstein reaction. Finkelstein reaction. That is it. Now this one which we have done today, AgCN. So carbon cannot attack on this position, so NC will be present. And in this one, KCN, C has the ability to attack on this carbon, and we have this CN. Understood, everybody?
Yes, sir.
Please note it down, and hope understood the session. And please do your homework. I will send you homework, and after noting down, you can leave the class. Assalamu alaikum, Yahya, how are you?
Fine, sir.
So have you tried the homework?
Yes, sir.
But I didn't see your homework in the, have you submitted it?
No, sir, I forgot to submit it. I only tried it. I had to submit it. I
Can you submit
submitted it.
it
Sir, my phone is on charging. Can I submit it
now?
after the class?
Okay. See, when you submit the homework now, and when teachers see your homework and he check it, then and when you observe the checked copy, you will get means more knowledge or more understanding if you have done something wrong, right?
Yes, sir.
So homework submission is very important before the class. That would be means better option for you. Ring expansion, you have done this ring expansion thing,
Ring inspection in
carbocation rearrangement.
yes, sir. Yes, sir. In the previous class or in the homework or also?
In I think means before 3-4 classes.
No, sir. We haven't done that. I took my notes.
Okay. So So meantime, you please note this down. This one, I think, acha carbocation rearrangement done.
No, sir. No, sir. We didn't do carbocation.
I think you should write this down because this organic chemistry is, very much interrelated with each other. So please note it down. And this is, I'm just letting you know, this is a concept actually. Uh, Siddika. Salam Siddika. So you haven't submitted the homework. Have you tried? I won't be able to use my mic today as my earphones are broken. Okay, no problem. Just be responsive in the chat box. No problem. You can, but just just message me or respond when I ask some questions. Siddhika, have you do you know about this carbocation rearrangement? Carbocation rearrangement. Okay, good. Ring expansion. Good. So these are important concepts. It involves stability of carbocation. Uh, uh, Done here?
1 minute, sir.
You don't have to draw this one concept thing. Okay. You know the hyperconjugation effect?
Yes, sir.
Plus H effect. So you don't have to draw this. Just do
Just
this.
Just the above part and the ring expansion above the ring expansion.
The questions only. The questions only. Please look into this, Siddhika. Meantime, yeah, you have only 1 minute left to copy this. Siddhika, do you know what is the reason of ring expansion? Why ring
Done, sir.
expand? Good. Okay. See, you have written ring expansion thing? Yeah.
Yes, sir.
Okay. See, the reason I'm just explaining, the reason behind carbocation rearrangement is stability. As alpha hydrogen has been increased from 4 to 8. So obviously, because of stability, carbocation will rearrange itself. Okay. It hydride shift is also possible, and methyl shift also possible. Okay. So that is why, see, in this one also 3 alpha hydrogen, 7 alpha hydrogen. The ring expansion take place because of, see, angle strain. Carbon bond, this all carbon, can you see, are in sp3 state in this ring, right?
Yes, sir.
So sp3 carbon, sp3 hybridized carbon are at angle of 109 degree, right?
Yes, sir.
So currently in this butane thing, in the 4 square thing, they are at 90 degree. So there is very much angle strain present here. Okay. So like 10 and 19 degree angle strain. Okay. So that is quite unstable. That is why ring is expanding and forming a pentagon structure, which and its angle is around 108 degree. Okay, so there is much lesser angle strain present here. Okay, understood? So
Yes.
the reason behind this is angle strain. So then there will be no problem, है ना? So this is the major reason of ring expansion thing, and thus stability has been increased. Done? Understood?
Yes.
Siddhika? Take. So let's start this today's session. The question where which I have sent you, Siddhika, please